Okay, so I think we've got a bit to cover, so I might make a start now. So good afternoon, everyone. My name is Paul Lavey. I'm the Research Events Officer at Swinburne Research, and thanks for joining us for today's July Smart City Seminar. You'll shortly hear from Dr. Saima Aijaz, who is the Research Scientist for Ocean Modelling at the Bureau of Meteorology, who will introduce the session today. But before I hand it over to Saima, I'm just going to run through some basic housekeeping. So obviously, most people know the score. So if you've got a question for the panel, we will have a Q&A session later after the presentation. So feel free to drop that in the chat or Q&A. You can also raise your hand and I will enable your microphone so you can actually ask your question verbally. And also just to let you know that I am recording the session. I'll distribute this to everyone afterwards. If you feel uncomfortable with your voice being recorded in the final recording, just let me know and I can edit that out afterwards. So at this point, I will hand over to Saima with today's session. Saima, over to you.
Thank you, Paul. Good afternoon, everyone. And before we start, I'd like to acknowledge our First Nations people. So we respectfully acknowledge the Wurundjeri people of the Kulin Nation, who are the traditional owners of the land on which Swinburne's Australian campuses are located in the Melbourne's East and the Outer East, and we pay our respect to their elders past, present, and emerging. So welcome to the seminar series, and today, as we all know, our topic is See No Evil, Can Coastal Communities Plan for Climate Risk? And you know, as we all know, that coastlines are shaped by the winds and the ocean swells. Beaches are routinely lost and, however, recovered. So one storm may strip the beach of sand, but another storm comes along and the beach gets recovered. So they've been shifting for centuries, we know that. But we also know that in recent, more extreme events, beaches have been lost and homes have been destroyed. And while sands may come back, the homes and the beaches may not recover. And we know that these extreme events are being affected by climate change. So today we have the seminar here and we pose this question as scientists, as a broader community, that what can we do to plan and how can we manage this risk? So let us hear from three eminent speakers today. So the format is going to be each of the speakers will speak for 10 minutes. And then afterwards, we'll have question and answer sessions. So it's really mostly about the questions. We'll try to have at least 20 minutes for the questions, if not more. So I'll wrap up. And so please, as Paul has already instructed, ask your questions, feel free to ask, and please, when asking your question, you can either ask generally or if you want particularly to address a speaker, you can choose their name and address to them. So with that, let me introduce our first speaker, Julian O'Grady. He's a coastal research scientist at the CSIRO, and he will talk about the coastal hazards in Port Phillip Bay. So Julian, to you.
Okay, thanks you, Saima. Can you see my opening slide in presentation mode?
Yes, we can. Yeah, we can.
Awesome.
Yeah.
Thank you. Okay, so this is some recent work that we've done, which will hopefully be publicly released soon. Looking at mapping the coastal hazards around the whole of Port Phillip Bay here in Victoria. It was a very large project. I've listed the authors down the bottom there. We're mainly from CSIRO. Some are from the Data 61, which is the digital branch of CSIRO. There's work from Federation University here in Victoria and some private consultants that have also helped with this work. So we undertook the work to look at the hazards around Port Phillip Bay. in the context of looking at the Victoria Marine and Coastal Hazards Act, Coastal Act. So the Port Phillip Bay is there to support the implementation of the Marine and Coastal Reform Final Transition Plan to help address the findings of the Victorian Auditor General's Office report. So looking at the protecting Victorian coastal assets. So the Auditor General's report found that coastal assets in Victoria are not well protected, and made recommendations that we have to improve our understanding of what the hazards are around Victoria. So the DELP approached CSIRO to undertake a detailed hazard assessment. And I'll just provide a bit of background about that sort of the hazard assessment that we provide. And I guess all of this is applying to the coastal zone. And here is a diagram from the policy, which shows where the coastal zone is. So 3 nautical miles from the high tide mark, extending 5 kilometres inland. So the whole of Port Phillip Bay hazard assessment looked at inundation, erosion and groundwater. So the inundation being, land that is flooded from the ocean, either temporarily or permanently, erosion of soft sort of sandy coastlines or high cliffs, and also saltwater incursion into freshwater aquifers from sea level rise. So all this information was fed into from a detailed hydrodynamic modelling simulation study of the whole Port Phillip Bay, looking at currents, water levels and waves. And that was that information was forced by detailed winds, downscaled winds from climate models. So giving a really high resolution, detailed analysis of what the ocean conditions are, or the bay conditions are, to inform these coastal inundation hazards. So in developing the inundation hazards and the overlays and how they're used, we engaged in stakeholders, so the local councils, as well as government departments, including Melbourne Water, to sort of understand how we can better present these hazards to inform risk and build improve our understanding of what the hazards are. So we did that with the use of a development tool, a decision support tool, which is a web-based platform where we could show some of the hazard information as overlays on imagery. We work with stakeholders to work out what the best way of presenting that data would be to sort of in future work to look at risk. So here is a map of Port Phillip Bay. I'm sure many people are familiar with it. There's lots of hazards when you get a big storm. This is, for example, there was a big storm in 2014, in June of 2014. There were large waves in the bay. It's only 60 metres across, but when you get really strong winds, you can generate quite large waves in the bay. As an example, down at the bottom left here, we have big waves observed at Frankston, which caused sort of yachts and boats to end up on the shore. Coastal erosion at the northern end of the bay. We saw large waves run up the coast and impact the Brighton beach boxes and cause hazards to their coastal erosion and inundation. And there was also overtopping. So when waves hit a coastal defence structure, water can flow over the top. So in this hazard assessment, we're not just looking at how high the waters get, but also these dynamic processes. So waves running up the coast and also overtopping structures. So to look at all these complicated inundation hazards, this talk will just focus on the inundation hazards of the full assessment. We use the CFAST model, which is it stands for the City's Flood Adaptation System tool. And what it does is it's a dynamic flooding. So you raise the water at the boundary and water flows in, and is time dependent on how far inland the water can encroach. So if there's protection structures there, then the water won't pass it. There also includes drainage networks. Down the bottom here, we can see a map of northern Port Phillip Bay with all the coloured drainage networks. And the water can actually flow through those drainage networks in this modelling system and redistribute the water. And sometimes water can actually go from the bay and up the pipes and cause a backwater flow. So there's an image here of a drain pipe and water flooding in there. We developed this tool to include shortwave overtopping, so individual waves overtopping seawalls and causing discharge onto land and causing flooding. So we developed that tool to really understand how the protection structures work. So we did all this in the context to look at hazard, and we did that in detail for urbanised low-lying locations in Geelong, northern part of Port Phillip Bay, in the west and in the east. But the real power in this tool, in the future analysis, is that you can change these sort of the drainage networks or the protection structures, and you can look at adaptation options. So it's a tool that could be used in the future to look at, what the current hazard is, and when you adapt these coastal infrastructure, what the future hazard might be. Because the overall hazard assessment that we undertook didn't look at what happens if we change or we adapt to climate change. So we had data sets on coastal protection structures all around the bay for our modelling study to see where a wave overtopping might cause inundation. And we had drainage networks in the low-lying urbanised environments. And our approach was, the approach that was required from the department or DELT was to not just look at a deterministic one sort of outcome of coastal inundation for a future sea level rise or current sea level rise, but to look at a probabilistic. Can you include uncertainty? So we looked at the uncertainty in the modelling estimates, and we came up with 3 different zones for different likelihoods of inundation. The deterministic sitting along the interface between the 2 blue zones, but there's a higher, in the purple area, there's a higher likelihood of coastal inundation. So from the detailed urban flood modelling, we're able to look at modelling sensitivity when there's no sea level rise on this left column here of the map of northern Port Phillip Bay, and on the right with a sea level rise scenario. More information on these layers provided once the public release of the report, but it shows what the current sort of storm tide, when the water levels rise during a storm, what the flooding will be now and with sea level rise on the top row. The middle row shows when you include overtopping, what the effect is, and we see the known overtopping occurring in locations like Altona in the west of this diagram, to the left of this diagram, and along the Middle Park region or the Beaconsfield Parade, where we know that there is overtopping occurring during design storms. So the bottom plot shows that when you include rainfall, sort of rainfall on the grid in this inundation hazard assessment in the drainage networks, we see a lot of pooling of the water from the rainfall in low-lying areas and in the catchment areas. So our study didn't just look at the urban environment and the inundation that occurs, but also in the natural environment. So here's 3 images of, on the top left, we have a protected dune with a fence in the northern part of Port Phillip Bay, and this is during the 2014 event. The middle is along the Mornington coast. There's a cliff there, you can see, and a boat's washed up there. And on the right is the Brighton bathing boxes. So you can see these 3 natural environments are also important assets to the Victorian community and can be are exposed to the sort of hazard. So we use some engineering approaches to understand how far coastal waves that are generated in the bay, how far inland they will move from the shoreline into the back shore or into these coastal assets. So using basic sort of empirical observational studies to understand, to predict how far inland they would go. And we're able to develop some layers where we're able to understand what's the wave run up hazard into these zones. And these 3 plots down the bottom here corresponds to the top plot showing what the likely wave incursion into the here on the left, the vegetated dune or the cliffs or the Brighton Bay box. So these bottom plots are showing what a user might see in the decision support system to help them inform what the potential risk might be. Okay, so that was a quick overview of just the inundation component of the hazard assessment. So thank you.
Thank you, Julian. Perfect on time. So please, write your questions either for now in the chat, and then later you can ask them. So let's move on to our next speaker, Kane Church. He's the environment coordinator at the Moyne Shire Council. And over to you, Kane.
I assume you can see my slides now.
Yes.
Full screen, hopefully.
Yes.
Yeah, so I'm Kane Church from the Environment Services Coordinator at Moyne Shire, down in the southwest of Victoria. And yeah, I've pretty much, it's not a dumbed down version, but no technical jargon in my presentation today. It's more an overview of what we have down here and the complexities that we are trying to deal with in either protecting or removing ourselves from the edge of the sea as sea level rise comes through. Let me find my cursor and we should change. So Moyne Shire obviously is down in the southwest. We've got 5,500 square kilometres and a roughly 90 kilometres of shoreline that we co-manage with Parks Victoria and DELP, Department of Environment, Land, Water and Planning. Pardon me. So in relation to the world and where we are, you can see the red dot there. We're down in the southwest and southeastern of Australia, Indian, Atlantic and Southern Ocean. You can see there's no real landmass between us, South America and right through to us. So the winds start picking up through this area and they're called the roaring 40s and the furious 50s and the screaming 60s. So you can see we sit here around the 40-degree mark, which creates a lot of wind through here, and then also on top of that swell. So yeah, animations. And this is this week's forecast for the wave swell from the roaring 40s. Over which Julian alluded to as well, 2014 we had a major incident, which the whole southwestern / southeast of Australia was hit with large storms. So that's where we're placed there. In context, this is Port Fairy. So the next few slides I've got of pretty much the 2014 and a few others. Since 2014, we've probably had 3 or 4 different storm events where we've had inundation and damage along our coast. So along here is South Beach, which is Ocean Drive, which at the moment about to go to expressions of interest to figure out what to do to protect their houses and or adapt this whole section along here. Here is Griffith Island and the Southwest Passage. Back in the day, around 150 years ago, they redirected the Moyne with training walls out to here, and that's actually made a lot of sand. This used to be 2 islands, Rabbit Island and Griffith Island, and all the sand's banked up. In consequence to that, East Beach has been depleted roughly 500,000 metres of sand. But in that, there was a passage through here that was developed for when the big swells come, it would actually flush the mouth of the river of sand, but they found out that once they had swells and boats were coming in here, they were pushed up against the northern shore, so it was closed down here. So the next few slides are the impacts that we've had over the years. So we'll start along here at South Beach, move on to Griffith Island and then along East Beach. Another thing that we have in our dune system up here are 2 old landfills which are going to be impacted and were exposed in 2014, and I'll talk a little bit more about that later. So this is South Beach. In 2014, you can see the swell that's generated there. It's about 8 metres, 6 to 8 metres coming through, and the house you can see in the corner of the photograph there, I call it the seaweed house, because in my time coming down to Port Fairy and now living here for 3 years, but coming down for a good 20 odd years, I've seen that house with seaweed up against its door about 4 times, which is that. This is the most recent one that I've had it happen in around 2020, I think that one was. So those waves just come, they crash, there's rocky reefs out in the bay there, and then the wave run up and just comes over and ingress into those areas. So that's something, if anyone knows and ideas how to fix these, that's where we're going to next. This is a little bit further along, called Pea Soup here in Port Fairy. This house up here is called the Breakers. Now we have a large rock revetment that's around that edge of the beach, but it's also depleting the beach of sand now. And yeah, we've obviously replaced our infrastructure to go back in. So yeah, 24th of the 6th in 2014 is when that significantly eroded along there to the house. This is the passage. You'll see this slide again soon, very, very soon. So the swell in 2014 again comes through here, and this was that revetment that I was talking about of the river that used to flow through there and go out to the bay on the other side to flush the sand. Now it's closed off here where that telephone pole is, and the waves come in, hit the protection structure there, and then over top, and then flood through here, and you end up with large boulders on the road. Again, it's happened about 3 times since I've been coming down to Port Fairy. Last time was 2020, but we actually actively monitor this area because it's a Griffith Island. We probably have over summer 200 to 300 people go around there a day. But in winter, obviously, when the larger seas come through, we actually close it and we've got predictions of when we think it'll overtopple the causeway, which is what you can see there. So you definitely don't want someone walking across that when waves are coming through like that. And that also causes damage on the island, and a lot of signage and stuff was wiped out and have to replace. Round the other side, so this is East Beach now, near the old landfills. This one was in 2020, not 2014. Yes, it is from the storm surge, but it's also terminal scour from a rock wall that's behind the photograph. But you can see the amount of sand. We lost about 3 meters of sand on the beach in 2020. And then in 2014, it actually exposed the waste in the landfill. And then, yeah, it went to the Prime Minister with ministerials, this one. And then we had to come up with engineers and put a wave energy dissipation structure in front of our landfill. So the waves come, it's meant to deplete the energy of that, and it still will topple over a little bit. And then this is 2020, where we had sand up to nearly the base of the rocks here, and then one storm event made it disappear. But up the other end here is where that wall was of the erosion. I'd rather that, and then back here where the waste is. Another thing that Port Fairy has had for a long time, 2013, we had a coastal hazard assessment undertaken, and also with the state doing one as well. Our predictions down here at 2100 is 1.2 meter sea level rise from 1990 and 2005, I think. But you can see it's going to, if it comes through, we're going to have impact of all the houses along East Beach, and our landfills up here. That's going to be halfway through the Moyne landfill and all the way through the Dulp landfill here. So they're the issues that we're dealing with in council and trying to work our way through. And then it's the options and who wins of the different approvals processes and what people are actually going to want. Do we want to defend Port Fairy, which in a couple of years ago we went through that and council decided to defend, so build rock walls, but that is starting to change a little bit as we keep going through and climate change keeps impacting Port Fairy. It's as you know, I've just alluded to, South Beach along here, we're going out expressions of interest to try and mitigate the sea level rise coming through and how we should manage it. One good website to go through for Victoria stuff, all this is online at CoastKit. It's a brand new tool that DELP have developed, and it has a significant amount of information for people to look at, and you can even go down to finite level and figure out where you are and how much sand's been removed from the beach and that sort of thing through Coastal Kit and Propeller, which is another information source that we can go to. But yeah, that's my quick introduction to Port Fairy. This is Port Fairy, as you know. There's roughly 95k or 90k of coastline that we co-manage. Another issue area we have is Peterborough over to the south, the east of the Shire. And it has similar implications as Port Fairy, but doesn't have as much beach. It's got more soft eroding cliffs into car parks and houses as well. So it's a never-ending tide of ocean coming to us. And yeah, we just got to learn to live with it and work out how to adapt. Thank you.
Thank you, Kane. Certainly, we have to learn to live with it. And yeah, you've mentioned some interesting toolkits there, so I hope we can look them up.
Yep.
So we'll move on to our next speaker, Professor Richard Manasseh. And those of you at Swinburne, you'll be quite familiar with Richard. He's a professor of fluid dynamics. And today he'll be speaking about the wave energy converters and how they're used for coastal protection. So Richard.
Well, thanks very much, Saima, and thanks, Kane, for those basically dispatches from the front line of coastal protection. So what I'll do now is do a bit of a share screen. Get the right window. Can you still hear me? Hello?
Yes, we can still hear you.
Yeah. Right. Just can't find the Zoom window to show the share screen. It's disappeared.
So it should be a little green arrow. If not, I can bring that up.
Yeah, it's funny. I've got the Zoom cloud meetings. Join.
Next to Q&A.
You were all there a minute ago, but you've disappeared.
All right. Well, look, I'll bring that up for you. Just give me a few secs.
Yeah, it's funny.
All right, just bear with me for 2 secs, and I'll bring that up for you, Richard.
I might actually drop out and come back. That might be faster. Oh no, I've got you. You've all come back. Okay. All right, now let me try doing the share screen.
Oh, yes.
What can you see?
Yeah.
Yes, we can see the whole screen. So that's great.
You can see what Kane advertised you would see. Once again, the scene of Ocean Drive at Port Fairy with waves sloshing over it. So waves aren't, as you heard from Julian, waves aren't the only thing that cause coastal hazards, of course. Can you still see the screen all right?
Yep,
yes,
we can.
Yep.
Yes.
So, but the waves are one thing that we feel that we have some chance of controlling. So I'm going to talk about the use of what's called wave energy converters, or rather the possible use of what's called wave energy converters to control coastlines. Now, Kane showed that map, which I'm very glad he showed, showing you the roaring 40s winds. And what this map is what those winds create. So where you see the dark red on the map, that's where you have very high wave energy. When I talk about waves, we're not talking about the little choppy waves that you might see from time to time on a small lake or on Port Phillip Bay. We're talking about ocean swell. And as Kane mentioned, you've got winds blowing for thousands of kilometers of ocean. And as these waves travel, they get longer and longer, and they also get higher and higher. And as Kane mentioned, here in the southern part of Australia, we are on the firing line of some of the biggest, meanest swell on the planet. Of course, the fact that you have so much energy in the waves has been noted for a very, very long time, centuries, and it is for centuries, in fact, that engineers have been trying to come up with machines to extract renewable energy from ocean waves. But we're not there yet. We don't seem to have wave energy converters everywhere in the world like we seem to have wind turbines everywhere, at least wind turbines everywhere in those mid-latitudes where we got the strong roaring 40s winds. And why not? Why haven't we had wave energy converters developed up to now? I think there's really two reasons. These reasons both come from the fundamental physics of waves. There's a very simple difference that I'm sure everyone will appreciate between the way water is set into motion by waves and the way water moves when it, for example, comes out of a dam. Comes out of a dam, goes downhill, goes in one direction. When waves come along, water goes one way in the crest of the wave and the opposite way on the trough. And therefore, you need a different sort of mechanism. You can extract renewable energy from water coming out of a dam. It's been done for a very long time with a simple single moving part, but you need some kind of machine or mechanism, and there's no obvious single mechanism that does it for wave energy. And so instead of a single simple concept that everyone knows like a turbine, you've got an enormous number of concepts. And the way in which we develop technologies in the Western world is we expect people to invent things, and then venture capitalists invest in those inventions, they form startup companies and so on. The second issue, which also comes from the physics, and ask me later and I can explain it if you want, but the second issue is that to get wave energy to work at all, you must have machines which are physically gigantic. So there's a mismatch. You have companies which tend to be very small startup companies trying to build something gigantic. So there's the giant clam, there's the giant penguin, the giant snake. They all look different. They're all different inventions, but at the end of the day, somewhat ironically, they all use the same underlying operating principle, that of resonance. That's the way they extract power from waves. Because of the size of the machines, the small size of the company, they can get it to work, and there are very many working inventions out there that have been tried and tested for years and years. But if they can't get enough money together to get it to work at scale, the company goes under. Company goes under, and the new company has to start with a new invention. That's the problem with wave energy. It's not that it doesn't work, it's the whole financial model doesn't work for this sort of system, which is really infrastructure and not the sort of thing that an IT startup might come up with. So coming back to the issue of protecting coasts, we're not the only ones to have noticed that wave energy converter machines do something that other renewable energy technologies don't do. And that is, of course, remove energy from waves, energy which, as we have heard, can be damaging. We can, as Kane said, of course we can build walls in the sea, breakwaters or submerged breakwaters, or we can build waters along the coast itself to protect the homes behind it. But walls are permanent structures. If we build a wall out to sea, it will permanently alter the marine ecosystem in the lee of the wall. And if we build a wall on a beach, well, then the beach may well be gone, and that's it. With wave energy converters, we have the potential for control. That's the word we're most enthusiastic about, control. So we don't have to have a permanent feature. We can extract power from waves when that power is potentially damaging. And rest of the time, possibly, we can generate electricity to return something from the investment made. So we don't want people to think of putting walls in the sea. We want people to think of, if they want to think of anything, arrays or farms of machines with spaces in between them. The peculiar physics of wave energy means that even if you have spaces between your machines, they can, if you set them up properly and if you turn them to the correct settings, potentially be as effective as a wall. So this is, on the left-hand side, is an artist's impression of a development that was slated for Portland, Southwest Victoria, but never got off the ground or got into the water because of financial issues. On the right-hand side is an array of 3 machines that did operate perfectly successfully, but as a trial in Western Australia. Here is Port Fairy again, East Beach that Kane just showed you. And this is a calculation done by a colleague of ours as what might be the case if we put 60 wave energy converters, that's WECs, off East Beach. Here you can see in the zoomed in version, each wave energy converter casts a kind of shadow. The red are the high waves and the blue are lower waves. So that sort of particular zone of the beach where we're worried about, in principle, you could block wave energy from getting through that beach. But most importantly, you don't have to block it all the time. You could turn it on and you could turn it off. So to summarize, wave energy converters, they remove energy from waves. Perhaps we can use them for that purpose as well as for generating electricity. Most importantly, we have the opportunity to control them. So we might be able to remove the damaging wave energy only when needed. So if there's some kind of value in controlling the coastline, then we might be able to find some alternative source of capital to invest in this sort of infrastructure. It is infrastructure. And over a long period of time, that infrastructure could return revenue. So it's protection that could help to pay for itself. And that's what I wanted to say. Thank you.
Thank you, Richard. That was very interesting and amazing how that model waves that you showed blocking or reducing wave energy. So from red, which was very high wave energy, with the presence of those wave energy converters, it all turned to blue. So, right there, very, strong indication of how they work, and you've explained it quite clearly. So with that, I would now invite the audience to ask their questions. We've got one question in the chat box, but please feel free to raise your hands or put more questions in the chat box. I do have few questions as well, but I'd rather have all of you participate and ask your questions, and then I can ask few later. So maybe I'll invite Hung Lu. Would you like to ask your question, Hung? Yeah. Okay, if I don't hear from Hung, I'll just read out his question. So he's put in the chat box. Thanks, Julian. It's for your interesting presentation. For inland inundation, did you connect the surge from ocean via high-resolution river models? And what models have you used? Thank you. So Julian, would you answer, respond to Hung's question?
Okay, in terms of river input, so the largest scale all of Port Phillip Bay hydrodynamic simulations was run with SCHISM, the SCHISM wave model, hydrodynamic wave model, and there was input from discharge that was input from the Yarra and and another river in Port Phillip Bay. That's just escaped me. But there was discharge that came in over the high cast period. So from, I think it was 1980 to 2014, there was input for the actual CFAS urban flood model that we use. We consulted with Melbourne Water, and in terms of the catchment flow, it's really just the local catchments that cause the flooding, the flooding that coincides with the surge. So we did on-grid rainfall, which then within that grid model, that was the catchment. And the expectation was from Melbourne Water was that far-field catchments, like the ranges, have a lead time of about 2 days. So we thought that might not, in the design storm that we evaluated, might not align with the storm surge to look at the design impact of inundation. So in that sense, the detailed modelling of rivers was probably through the SCHISM model.
Thank you, Julian. So what you're saying is that, yes, sort of you have connected the ocean with the river models because you are using downstream boundary conditions which come from, elevated tidal levels and surge, and you've used them as inputs into your river models. So in effect, they're all connected. So that's, and to give a realistic picture as possible of the inundation, which is a cause of coming both from rain as well as the storm surges from the ocean, as well as from the sea level rise. So that's good. So just following on from the same topic, I noticed that, when you produce your flood overlays, they're probabilistic, so which is really good, because really it's the uncertainty that's, which gives you an idea for planning that, look, if it is flooding, but there's a chance of it only 1% happening, it's not worth planning for, because previous studies normally just give a deterministic flood overlay. And that brings me to my question that there are a few very comprehensive studies done in the last few years. So specifically, I think for the Future Coast program that DSC now delved. So they had very comprehensive coastal hazard assessments for Bellarine Peninsula, and so that covered a lot of, pretty much the western region of the Port Phillip Bay. And then there was another one, the Port Phillip Bay Adaptation Pathways, which is a little bit older, 2012, but that was done, initiated by the Association of the Bayside Municipalities. And they all looked at, pretty much what you have described, river hydraulic, hydrodynamic river modeling connected with the ocean surge and tidal levels and sea level rises. And they also produced these flood overlays. They were not probabilistic, but they were for different scenarios. So in case of a 100-year rainfall combined with a 10-year surge. So my question is that they produced some flooding zones, which were quite spectacular for 2100, reaching into almost, 5 kilometers inland. Does your models, you've got a more updated one and it's probably a lot more sophisticated. So have you compared them, and is it, giving you similar results or less inundation or more inundation?
Yeah. So I guess you're familiar with the sort of the bathtub style of inundation that also has occurred previously, where our study with the CFAST model, we modeled down to 5 meter and did dynamic inundation. So the bathtub inundation models do tend to overestimate or provide a higher estimate of inundation, typically, because it's instantaneous water flowing and disconnected parcels of land can be inundated from the ocean. So ours doesn't quite encroach as much. So there's a time dependence of the water and the overtopping as the tide goes up and down, so it's dynamic at the amount of inundation that occurs. So yeah, some of our analysis and talking to, Melbourne Water are probably the people who know best about the flood overlays. There is still uncertainty in our models. We try to cover a lot of model uncertainty, but there could still be space for a freeboard for higher levels of inundation for things that our model doesn't account for, like things like, well, what happens if a drain gets blocked, or what if there's a grate and all this debris gets into a drain. Our model can't account for that, but it should be considered for a hazard, I guess. So there has to be allowance for a freeboard and some differences between the models.
Thank you, Julian. Though just a note that not all of the previous studies were bathtub models. Actually, yeah, they did both, but yes, the bathtub, certainly it does give you higher flooding. So, and yours would be more accurate. So, we've got another question from the audience. So, Paul, would you like to ask your question yourself? Paul, could you, yeah, okay, we've got you unmuted now. Paul Bierman, I hope I'm pronouncing that correctly. So please, yeah, and Julian, you've got another question from Paul.
Yeah, hi, apologies. My internet connection seems to be struggling at the moment, so hopefully you can hear me. Yeah, thanks for your presentation, Julian. I'm interested in the application of this decision support tool that you talked about, and apologies if I missed it during the presentation, but I'm thinking, is the scope of that to be used sort of in an operational way in real time during storm surge events, where we may be able to use a prediction of water level at a tide gauge to see what parts of the coast may be inundated or impacted by by seawater or waves, or is it more for sort of planning purposes based on some scenarios? Because certainly be interested in hearing more and learning more if it is that first case.
Yeah, and it definitely is being used. I think that aim is for planning rather than sort of disaster mitigation or hazard forecasting. So the tool is really a demonstration tool. It was an opportunity to engage with the community, with the stakeholders, to show the potential of the work, to show how our hazard overlays could really inform future incarnations of a decision support system or a platform. I know Kane showed a really good platform there. You know, there's no reason why the data that we generate can't end up there, but it was just an alternative method that CSIRO was developing, or Data 61, the digital branch, developed to really as a test case to demonstrate what we could do.
Does that answer your question, Paul?
Yes, thank you.
Yeah, so just to follow up from that, Julian, I guess, are there plans to make it into an operational model, something that could be integrated with the Bureau of Meteorology's data, you know, on a sort of few days in advance or something like that to predict what might happen?
No, not at this stage. I mean, the Bureau does have storm surge modelling, but not to the the urban scale where you can actually. I mean, it'd be quite detailed to get to the drainage networks, and there was a huge amount of computational effort went into looking at the drainage networks and overtopping and so forth.
Yes, that is true, because yours is extremely detailed, very high resolution. And the Bureau of Meteorology, it does issue its flood warnings about 4 days at most in advance, but they rely on a lot of measurements around from, river gauges, from tidal water levels. And they do have a national storm surge model, but it is not of as high resolution as to go into the city. So it does, and it doesn't do inundation. It will predict storm surge levels around the coast or generated from tropical cyclones, but it will not, it'll present a risk of inundation based on storm surges or river heights, but it does not do what Julian has just described in very detailed. So we were talking about planning, and I thought that we might ask Kane, because, after all, he's from the Shire of Moyne, and the local councils are responsible for planning. So my question was that you mentioned that study that was done back in 2013 and 2014. Again, it was part of the Future Coast program and looked at coastal hazards and produced flood overlays for Port Fairy specifically. And I remember looking at that report, and there were a few recommendations made, well, several recommendations, including repair of the seawalls, training walls, causeways. It did, I thought it, recommended a few more seawalls, but as you are saying now, that was back in 2014, seawalls are probably not the best way. The report also recommended vegetation and so on. So is the council looking at alternate ways, or are seawalls still the preferred method? And what other modes of sort of coastal protection is the council looking at?
Yep, thanks for your question. So at the minute, as I alluded to in the presentation, along Ocean Drive, South Beach, we're open to anything. And the best way, I'm treating it as an option, as options analysis. So I don't particularly want a rock wall, but if that's the best option for the time and the sea level rise to 2100, we want to try and protect against, we'll go for that rock wall. But if a wave energy converter can be put along South Beach, I'll take it any day, and turn it on and off so my sand doesn't disappear as well. But council's stance on it is, be adaptable, and just see where things are going, and always look at alternative technologies, and also don't just go rock wall. I know I said defend Port Fairy, that was around 2017. They come out and said defend, but now I've come on board and I'm saying, well, putting a rock wall, you're going to deplete your beach, and how you're going to keep replenishing your sand. Also, at the moment, we've got a C69 planning going through, and that's against sea level rise at the moment at 2100 at 1.2 meters, but that's been set to the planning minister and a panel to determine that for us. The IPCC report will also come in conjunction with that one. But on saying that, the planning panel could come out and go, yes, do 1.2, here's all our flood models, and then someone puts in an application within that flood model. It's up to council, which sometimes they go against officers' recommendation, and they'll allow someone to build in a flood zone still. So it's sometimes very subjective.
Very tricky, yeah, to deal. But you did mention those sea level rise projections and what's used for planning, 1.2 versus others. And when most of the studies are done, because there's no hard rule, so pretty much scientists or consultants decide their own thresholds for the sea level rise. Is that correct?
Generally, and it comes back to the technical advisors in council, and back from 2013, it was pushed by Department of Sustainability and Environment back then to use the 1.2, which we're still using, but then I'm wanting to build rock walls out to protect their landfills, and then they're going the best guidance that we have at the moment. I think it's 0.834 from the IPCC for construction. For overtopping and stuff, and wave modelling at 2100, which is through the Marine and Coastal Act, and then the strategies and the policies that are coming out of that as well.
Right, thank you. And you did mention wave energy converters and new technologies, so I think we'll go over to Richard now. And yeah, well, there is a question for Richard, so maybe I'll ask Kath Phillip, if you'd like to ask your question for Richard.
Need to unmute Kath.
Paul, are you able to unmute Kath?
Oh, sorry, yeah. This is Kath. Hi. Richard, yes, you brought up the CCE project. I'm just wondering whether you've got an update on how that project is going. I think you said it was a pilot that was done. So what's happened with that one?
Right, so there's been a long history with Carnegie Clean Energy. That project was completed, I believe, in 2015, all successfully. And then the West Australian state government said that, well, they would invest in a wave energy farm in Albany in southwest WA, and CCE was to be one of the main contenders to construct that wave energy facility. However, CCE's finances were, being an R&D company, they were not making a profit yet, and so the finance gurus suggested that CCE buy a battery company in Western Australia, which was turning a profit. Unfortunately, the battery company went down and then took CCE down with it. Fortunately, I think it would have been in 2019, CCE refloated without the battery company, and they're back in business again. So, and once again, I think there's some talk about the development in Albany. So it's all sort of ups and downs, Kath. I'm afraid that's the way with wave energy.
Richard, what does CCE? Sorry, Kath, go ahead. I was just saying, could you please tell us what CCE is?
It's the acronym for that company, Carnegie Clean Energy. So I showed a slide with 3 actual wave energy converters in the ocean off Western Australia, and we had some input into the layout of those 3. So that was very exciting to see that development there. Yep. So yeah, it's almost like a quantum froth. Companies appear and disappear, and this company had very, very solid engineering. I mean, most of them do now, but anyway, but this company was very solid, that years and years of expertise. So I was glad to see it resurfaced in the end. And But ultimately, you know, I feel that, you know, it's heroic, the efforts that all these small companies are putting in, Kath, and it shouldn't be like that. I don't think, you know, we need sort of entrepreneurial heroism for the problems that we face. I think people need to be able to understand what wave energy converters do. They need to understand the issues, and ultimately governments need to understand the issues, because these are analogous to, say, building a dam, a hydroelectric power scheme. I hesitate to use that analogy because people think of a wall as soon as I mention the word dam, and that's not what we would do with wave energy converters. Nevertheless, the way in which a hydroelectric power scheme is operated is much more akin to the way in which wave energy converters would be operated. Large-scale infrastructure, it needs a government to make the call. It needs a government to make a call, because only governments are empowered to consult all the stakeholders that are involved. It's not a simple commercial exercise. It involves the environment, it involves many, many stakeholders. And that doesn't mean the government has to spend the money and build it. The private sector can do so, but the governments need to sort of be more proactive, in my opinion.
That is true. Yeah, true indeed. Richard, are there many operating wave energy converters in Australia?
There's one right now, as far as I'm aware. It's in King Island, Tasmania, in between Tasmania and Victoria. And it is on the lee side, on the eastern side of King Island. It was very carefully placed there so that it wouldn't be subjected to the most severe waves which come from the southwest, as we know. And I believe it's been delivering power to the little microgrid on King Island now for just over 1 year. So it's certainly operating. And it's of a type of wave energy converter. The basic principle was patented in the 1860s.
Wow.
How and used since the 1970s. Of course, they've got their own particular take on it, their own patent on how to do it, but nevertheless, it's a very reliable form of wave energy converter. So that's sitting there, and it's working as far as I'm aware. Elsewhere in the world, there have been many trials of wave energy converters which have operated for decades. There's one in northern Spain, which is actually also used for coastal protection. And that has been operating for 10 years now, delivering power to the grid. And that's an array of 16 machines. So it has been done, and it can be done. It's just not well enough understood, I believe.
Thank you. We've got 2 minutes left, but you know, I've got this burning question for Kane, and it is about, you know, you talked about protecting homes along the coast, and I know that New South Wales, we've heard in the news, it's always a, you know, complicated issue, but who is responsible for the costs that are associated with protecting homes? And especially if an individual home is at risk, then, you know, other than insurance is not sufficient. Like, for example, if it's going to be washed over in the next storm, or it's sitting at the edge of a cliff, you know, who is responsible? Kane, is there like an easy answer to this? Because
not really.
The government is struggling.
In Port Fairy along East Beach, we've got a rock wall that's 50, 60 years old at end of life. The state government has come out and we've obtained funding to protect public assets, but at the moment the state government won't protect private assets. So we have several residents coming to us saying, what are you doing about the rock wall? And I go back to them and say, nothing at the minute, but if you can get your neighbours together, maybe we could help facilitate and get through the approvals process to upgrade it in front of their houses. But it is another council report that I need to write and put up through council to get a decision on. I contest it because I live in Port Fairy as well, but I'm out the back blocks, not on the ocean. They chose to buy on the ocean. Why should council spend my rates to protect their house? So it's a contentious issue, and we will have to do some community consultation to get an outcome on that one.
Yes, it is a contentious issue. So thank you, Kane. And I guess we're at 1 p.m. and I'd like to thank all the speakers and the audience today for participating. So as we all heard that, yes, climate change does, it presents a lot of risks, especially for inundation, not just inundation, coastal erosion, safety of public assets, individual homes. And let's hope that the governments will be more proactive in managing these risks. Paul, I would turn over to you. Thank you for your assistance. And, maybe you can wrap up the final seminar. Thank you, everyone.
And thanks, Saima, for being a great host.
Yes, thank you, Saima. I'll just very quickly, oh no, I can't share that now. I had the smart cities details up, but that's gone. But because we haven't got much time, if you do have any questions, feel free to reach out to the smart cities team, which is sci@swin.edu.au. So thank you everyone for your presentation, really interesting, even for a pleb like me. So we look forward to seeing you at the next session in August. So all the best, everyone. Thank you.